Yo, what's up, YouTube? It's Crack Tombine. In the chemical calculation, no, not chemical calculation. I gotta do my physics assignment, and after that, I gotta study for my exams, and after that, I gotta do my chemistry assignments, and after that, I gotta do my Python classes, and after that, I gotta still do. I got a lot of stuff to do. That's what I'm tired. That's what I'm saying. Got a lot of stuff to do. Less than a minute. Pop the chat out. Pop, 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 poppity. Where the oh, really did work this time. No, so how does inserting a dielectric material between the plates of a capacitor inserting a dielectric material between the plates of a capacitor affect the electric field and the capacitance of the capacitor? So inserting a dielectric material in between the plates of the capacitor increases the capacitance as the dielectric material polarizes, which yeah, it polarizes due to the electric field between the capacitor that is between the two metal plates, which polarizes the dielectric material, which makes which results in taking in more electric charge overall between the capacitor, that is the increase in capacitance, and electric field between the plates decreases as the dielectric material polarizes and forms an opposite electric field, internal electric field with, which reduces the overall electric field between the two capacitive plates. I guess I got that right. What's the difference between the effects of dielectric plate and a conducting plate when inserted between the plates of a capacitor? So if a dielectric plate is inserted, the capacitance increases. Conducting plates is inserted, the capacitance does not affect or change, I think. Yeah, it does not change. Okay, those are the two questions. I'm guessing this time the physics is going to be easier. After submitting this, I have to do my chemistry assignment really fast, and I have to study for my math exam and physics exam, and I have to study Python. Yeah, the electric field decreases, capacitance increases. I was right. Dielectric reduces electric field but increases capacitance due to polarization. Conductor cancels electric field inside itself and typically decreases the conductivity. No, capacitance, unless it's negligibly thin. Okay, so conductors uh, cancels the E inside itself, typically decreases So conductor inside a capacitor decreases the capacitance. Okay, so how does a conduct between two capacitor plates decreases the overall. Let's see what they're saying. When a conducting plate is inserted between the plates of capacitor, it decreases the overall capacitance. The conductor plate shields the electric field inside itself because free charges in the conductor redistribute to cancel out any internal field. This effectively splits the original capacitor into two separate capacitors. Okay, each with smaller separation distance with an additional gap due to the conductor. The original capacitor without conductor separation D capacitance C. After inserting the conductor of thickness D T, the conductor divides the gap between two regions. Distance from the top plate conductor D1 distance is okay. So how does the capacitance decreases? It acts as two series capacitors if it's a conductor and what? The dielectric material also polarizes inside the capacitor, which results in the mm, formation of an internal electric field, which reduces the overall electric field between the capacitor plates. That's how the capacitor increases its capacitance when dielectric material is introduced. But in the case of conducting material, the it polarizes. Conducting material polarizes it for it arranges the electrons inside the conductor according to the electric field. I get that. Electric field, which so does it increase the electric field inside the capacitor? So conductor. No, conductor inserted between the plates of a capacitor does not increase the electric field. In fact, it shields the electric field inside itself, making it zero. However, however, the electric field in the remaining air gaps increases because the conductor redistributes charges. So, so a conductor, the addition of conductor to a capacitor decreases the capacitance. Yeah, I understand that it acts as two capacitor plates, decreases the dielectric material. Instead of the dielectric, now it's conducting. The amount of dielectric material decreases when conductor is increased. The dielectric material can be air, whatever, but yeah, I mean, for a capacitor, the polarization of the dielectric is what gives the capacitor its capacitance, and the introduction of a conductor to a capacitor always decreases the dielectric material or dielectric situation, which results in lesser polarization of the dielectric, which ultimately results in the lesser capacitance. Okay. So if Mhm. So the addition of a dielectric material increases the capacitance, decreases the electric field, which results in more power drawing or increase in capaciting charge, while the introduction of a conductor decreases the capacitance and decreases the ability of the conductor to hold the overall charge. Interesting. Interesting indeed. Okay, I think I got something. Hey Siri, set a time for 30 minutes. Gotta do this 30 minute trick, or else I'm not gonna do any bullshit. Lines and grids. So it's assignment 7. First one. Calculate the capacitance of the capacitive networks given in the figure below. So this is a parallel, this is series, parallel, combined to series, parallel, parallel, parallel. So it's a parallel connected to another set of parallels, giving the ultimate parallel. The two plates of a parallel plate capacitor. Okay, I don't give. I don't care. Mm. I mean, the first question I can do, but I'm testing my artificial intelligence. I'm testing the intelligence that people made. I do have. I'm not talking too much. Oh, I gotta take a shower. I gotta shave. Yeah, yeah, I didn't tell you. I'm getting rid of the Singham beard. I'm so sad, but I gotta do this, man. Will I do it this time today? If I do this today, it's a double, triple kill. Saying it, bro. The saying it. Okay, so what we doing? Electric field on a dielectric, bro. I'm not talking. So if it's in series, if it's in parallel, you just add them. This is the exact opposite of resistors. Yes, yes, it is very similar but opposite of resistor. So that's C1, C2, and C3. So C1 and C2 are in parallel, which so if it's parallel, then they are and C1, 2, and C3 are in series. Therefore, C total equals C1, 2 into C3 by C1, 2 plus C3. That is C1 into C3 plus C2 into C3 plus by C1 plus C2 plus C3. That's the first part. Now the second part. Now both are in two parallel connecting to two Two parallel connected by series. C1, C2, C3, C4. C total equals C12 dot C34 by C12 plus C34, which is C1 plus C2 into C3 plus C4 by C1 plus C2 plus C3 plus C4. That's B. Now the last part, C. We got we got two parallels connected in two parallel ways. That's the most parallel thing I seen, bro. Ain't nothing parallel than two parallel shit. But I'm getting confused. Two parallel connected as parallel. You know what I'm saying? Dear God, that's a recipe for making capacitors. That's what it's a recipe for. C1, C2, C3, C4. So C1, 2 is they are parallel, parallel. C3, 4 equals C3 plus C4. They are parallel. Now C total equal to C1, 2 plus C3, 4, as those two are also parallel, which gives C total is C1 plus C2 plus C3 plus C4. This is the most easiest physics question I ever seen, and the most easiest just came up on assignment number 7. What? I'm sorry, what? Now this there's values? No. Where did you get the values, bro? Oh, it's an example. Okay, now two plates of parallel two plates of parallel plate capacitance with area A and distance D apart from each other are charged to a voltage of 5 kilovolt. A conducting plate with the same area as capacitance and thickness A less than D plates is inserted. Give a schematic plot of the electric field and dielectric displacement inside the capacitor as a function of x coordinate. How does the capacity change due to the insertion of a conductor? Insert the conductor A now in a dielectric medium. Insert the conductor now in a dielectric medium with dielectric function epsilon and thickness A is inserted into the capacitor. Give a schematic plot of the electric field and electric field displacement inside the capacitor as function of x coordinate. How does the capacity change due to the insertion of dielectric? So I guess inserting dielectric increases the capacitance, But as there is already a conductor, the capacitance is pretty low. The introduction of the dielectric increases the capacitance, but I don't know how the exact numbers are. I don't know if the dielectric makes it more capacitor makes it a more of a capacitor or not. I don't know. Part D? What? There's just part D? Let's fucking go. Oh. Ah. Inside the conductor, electric field is zero because free charges in the conductor redistribute to cancel the external field. In the air gaps, the electric field increases because the same voltage now drops over a smaller distance. So electric field in the air equals distance minus the thickness of the conductor. So now that is higher than the electric field that it was. Dielectric D is continuous equals epsilon 0 E in the air gaps but 0 inside the conductor since D equals dielectric displacement. D is continuous and equals epsilon E in the air gaps but 0 inside the conductor since D equals epsilon E and E equals 0 for for inside the conductor. Okay. Schematic plot quantitative. Capacitance change. Capacitance increases because the effective plate separation decreases. What? What? So it was, yeah, two capacitors in a series. Do you think it two capacitor in a series? So now you are telling me capacitance increases with the addition of a conductor. What? If the conductor is floating, not connected to either plate. So addition of floating conductor or dielectric material increases the capacitance. Mm-hmm. Part B, dielectric insertion. Where is the equation with X? Electric field E of X, conductor E forces inside itself. Electric field exists only in the region outside the conductor slab. If the conductor is centered off or off centered, if centered or off centered, this in effect the idea field lines terminate on surface charges induced on the conductor. Let's assume that the conductor is placed between x equals x1 and x equals x2 plus a. Let's assume the conductor is placed between x, which is equals x1, and x equals x1 plus a. Then the electric field would be E0 e, if the x is less more than 0, less than x1, 0 if the value of x is between x1 and x1 plus a. That would be the conductor. Okay. And again, E0 for, okay. So x is the variable. Dielectric displacement dfx, there's since there's vacuum or air, dfx equals epsilon 0 e of x. So e of x can be epsilon 0 e 0 if the same, okay, 0 as, okay. The insertion effectively breaks the capacitor into two capacitors in series, okay. D minus a by 2 if inserted centrally. The capacitance increases compared to the original. Okay. Oh, I think this time. I think this time ChatGPT gave a better answer. So it's the second question to A. How do we start? So there are two capacitance plate. Two capacitance plate and dielectric conductor of thickness A. The distance between the conducting plates or the capacitance plates are D. And let's take this as X. These two are going to be X. No, no, that's wrong. X is actually a variable. Okay, though. Inside the conductor, electric field E equals 0. And for electric field only exists the area, the space outside between the conductor and plates. Assuming the conductor is placed x1 distance from both capacitor plates. So electric field E of x E of x would be, so the if the x is between 0 and x1, I can't cut it, right? Yeah, I can't cut it. I'll cut it and move it. That's perfect. E0. What is E0? Now let's just take E0. It's gonna be 0 if it's between the if x is between x1 and x1 plus a. The E0 if it's between x1 plus a greater than less than d. That's gonna be the electric field, and now it's the dielectric displacement. What is dielectric displacement? Also, there's values, right? 5 kilowatts. Froggy. 30 minutes. Yo, what's up, man? What's up, Froggy? What have you do, man? How's it go, man? Like, how's life going, man? I respect for checking out the stream, dude. You got that? It's good. You got that? You got that freaky text font. So, what are you up to, man? You play games? I'm here doing my physics assignment that I should be submitting until Monday, 9 a.m. But I have some more exams, so I'm gonna do this as soon as possible. Huh? Huh for your text, I guess. Do you play any sort of games, Froggy? Hmm. Yeah, what the fuck is this? Well, I play Undertale, still trying to do Geno. I'm I'm guessing that that's a boss or some sort, that's some challenge in the game, Undertale. I actually bought the game Undertale. I was planning to play the game. Then suddenly someone on the stream came up to me and said, I have to play the game called Deltarune, which is from the same creators for Undertale, and it's free. So right now I'm playing Deltarune once in a while. If someone in the stream wants me to play Genocide Route, okay, it's type of it's a type of difficulty in the game. I'm guessing. I haven't played Undertale. I just started Deltarune and I'm just a complete beginner in the game. Genocide Route. Okay, okay. Interesting. Dielectric displacement field is called dielectric displacement vector quantity used in electrostatic to describe how electric field interacts with dielectric material. It accounts for both free charges and bound charges induced in dielectric. It accounts for both free charges and bound charges. Okay. So, Froggy, do you wanna let me explain? A genocide route is where you kill all the monsters, and pacifist is where you spare all the monsters. Okay, okay, I get that. I understand that because I play a game called Lies of P right now. Every day, 15 minutes, I play Lies of P every day. And sometimes in the game, if I find the new boss nearby, I will decide myself to kill all the fucking NPC opponents on that area nearby just as a challenge. I would say that is similar to this genocide route. I feel you, brother. I feel you, man. Mm, do you want me to play Deltarune? Are you interested in? It's gone. Escape. Froggy, are you still on the stream? I don't think so. So, what is dielectric displacement? It's a quantity used in electrostatics to describe how an electric field interacts with the dielectric materials. It accounts for both free charges and bound charges induced in dielectric. Hmm. Dielectric displacement, vacuum permittivity, electric field, polarization, density. Uh-huh. Dielectric modifies E through polarization. In a capacitor, dielectric remains unchanged if the free charge suffix position. E decreases because P opposes. Okay. So stupid. Hey Siri, set a time for 30 minutes.
30 minutes. Counting down.
Oh man. Some of the bikes, bro, some of the road bikes, oh, they're just too beautiful. I'm just saying, man, some of the bikes just look so good. Price. Dun, 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 dun. Specialized Renrad. Oh, that's the name of the bike. I don't know what to do. It was one explosive metal, which was wrong, and the professor just shut me down straight away. No, something is not explosive metal. And the starting was pretty bad, but otherwise I did a fielding test. I did not wait. I was not given some idea what I should be saying, and I said everything I wanted to say. So that was that. But we should remember that when you react to metal, that it explodes when it becomes contact with water. That's what I should be saying. Yeah. I gotta do this. I'm wasting my time. I'm wasting my time. So that's the electric field, the dielectric. This so the directly show the electric field without a char or dielectric. Instead, it's a construct that simplifies calculation by separating the effects of free charges and bound charges. So it's the no, dielectric is not the overall charge inside the capacitor. It is a mathematical construct that simplifies calculation by separating the effects of free charges from bound charges. What the definition? D is equal to, okay, P polarization density caused by the bound charges in the dielectric. Key property: D depends only on free charges. charges on the capacitor plates. Gauss law for d delta A. Okay, this the okay. Bound charge, induced charges on the surface of the neutral ball. These do not contribute to D. I thought it's a sum of bound charge. Their role in E. Bound charges modify the net electric field. I get that. Opposing the field from free charges. Okay. Their absence in D is designed to ignore bound charges entirely. It is a mathematical tool to simplify problems by focusing on free charges. P represents the bound charges effect. When you add, the bound charge terms cancel out, leaving a quantity D that depends only on free charge. Worked examples. I might need to refer YouTube for the dielectric displacement because that thing is pretty. It's electric displacement field, right? No, I need dielectric. Vector. Okay. Hmm. Okay. I need to know what are the meanings of the first. Uh-huh. Surface charge is for the capacitance plate, I guess, right? Yeah. That's unit surface vector. Mhm. Oh no, bro. Reset the time for 15 minutes.
15.
Okay, so the bound charges are charges by the dielectric. Is that what it is? What's bound charge? Free charges. Okay, my number one guess is free charges are the charges from the capacitance plate, and bound charges are charges in the dielectric. Is that how it is? So, what are free charges on a capacitor? Bound charges versus free charges in a capacitor. Free charges, what they are. The charges physically placed on the capacitor, example by a battery. These are controllable charges that generate an initial electric field, so that are from okay. Directly determine the dielectric displacement field. Bound charges, what they are, charges induced on the surface of a dielectric material when placed on an exchange. So bound charges are related to the dielectric material or dielectric material. There's nothing. uh, when placed in an external fluid, they arise from polarization of the dielectric molecule. Mhm. Okay, without the dielectric, only free charges exist. Gotcha. Thank you, woman. Jen Foodbox. Whoa, now it's working. Free charge. I got you, man. I got you. Uh, so that is displacement, dielectric displacement. But here they don't give a shit. Look at this. Since there is vacuum or air, dfx equals epsilon zero. Dielectric slab inserted. Okay, so the first case, it's there's no dielectric. It's just conductors. So it's just free charge. It is raining. Okay, that's not good. Bro, what? What? Amazon Prime? Why? Why would at least Amazon just takes some money from my account? Why? So the dielectric displacement dfx equals epsilon 0 E of x. Uh, since there is no dielectric material, therefore no bound charges. Okay, so dfx equals epsilon 0 E0 Ex, right? No, E0. If it's 0, x is 0, x is greater than 0, less than x1, 0 if x is between x1 and x1 plus a. Epsilon 0 E0 if x is between x1 plus a and it's less than d. That is the equational functional representation of the dielectric displacement inside the capacitor. Capacitance change. The insertion effectively breaks the capacitor into two capacitors in series, each from distance, each of distance d minus a by 2. If inserted centrally, the capacitance becomes d minus e. Oh, yeah. Change in capacitance. So the change in capacitance is the conductor will breaks the capacitor into two capacitors connected in series if conductor is placed at the center, then the distance between the newly formed series capacitor will be d minus a by 2. Capacitance C dash equals epsilon 0 a by d minus a, which is higher than C0, which is epsilon 0 a by d. C dash greater than C0. That's that's the answer to the first part. Now it's the second part. Now we introduce a dielectric slab. Introducing a dielectric slab. The field in the dielectric region reduces due to polarization. Yeah, the field inside the dielectric is zero. That's for the conductor, right? Yeah. So the dielectric field is d by epsilon 0, which is epsilon 0 E0 by okay. Assume the dielectric between x equals x1 and x equals okay. So the dielectric is going to be the electric field is going to be the same as before for outside the dielectric, and inside it's going to be epsilon 0 by epsilon into E0. That is the ratio of permittivity of the air or vacuum by the permittivity of the dielectric material into the electric field outside. Dielectric displacement remains continuous, no free charge in bulk. By dfx equals E is okay, and remains continuous. Why? No free charge in bulk. Okay, that's the reason. It's gonna be epsilon 0 by E0 by epsilon 0. The electric field inside the dielectric is the dielectric displacement inside the I did not understand the dielectric displacement. It's 30 minutes? No, it's 15. A series set a timer for. Nah. I'm gonna do this question. I got a call, and I'll be right back. I got a call. I gotta clean my room. Oh, yeah, I'll do all that stuff, and I'll stream again after doing this question. I didn't get it. I don't get it. The dielectric displacement. What's the formula? What? Wait. What inside dielectric displacement inside the dielectric material is equal to. The formula for dielectric is epsilon zero into E, right? So the E for the electric field inside the dielectric is what? The electric field inside the dielectric the di- is the dielectric displacement by epsilon zero. The dielectric displacement remains constant. So what affects the dielectric? I don't get it. A conductor is not necessary, but rather is determined by the free surface charges. So in this case, the dielectric dis well for the it's same as outside. As the conductor had a lot of free surface charge, is that the reason why its D is zero? Inside a conductor, electrostatic case. I don't understand what electrostatic case is. I don't know. Free charges moves until they exactly cancel out any internal electric field. Okay. So in static equilibrium, we always have E equals zero. Okay, so conductors. Okay, the polar. Okay. So dielectrics have, what do they have? They have dielectrics have po- inside the dielectric there's polarization and there's going to be bound charges which contributes to the dielectric displacement, while the conductor cancels out every electric field. Therefore dielectric displacement becomes zero because dielectric displacement is the product of electric field multiplied by the permittivity of the material, or yeah, permittivity of the material. Therefore, no electric field, no dielectric displacement. Yeah, I guess I almost got it. Field inside the dielectric equals displacement by dielectric displacement by permittivity, which is equal to, so electric field is E0 if x is between x and x1, and the electric field is going to be epsilon 0 by epsilon e0 if it's between x1 and x1 plus a. It's going to be epsilon 0 if it's between x1 plus a and d. So that's the electric field. Now, this dielectric displacement. Dielectric displacement is what? That's dfx. And epsilon e. It's in the game. dfx. E0 into, that's gonna be giving E0 square by epsilon square, epsilon 0 square by epsilon into E0. That's what dielectric. If I let's see if it understands. No, I'm not talking about that. I'm talking about we wrote that so inside the dielectric slab So, inside the dielectric slab, what? E equals ER into E0. What the? So, there's still gonna be E. I don't get it. I don't get it. Yeah. Is equal to epsilon E dielectric. Oh, whoa, 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 whoa. What the? Mm-hmm. Okay. It's just the form. I didn't know the formulas. Okay. So, yeah, it's gonna be constant, but yo, I have Chulu. What's up, man? How's it going? It's been some time. Oh shit, my hair. How's it going, Terraria? What's up, man? Fine. How about you? Yeah, I'm doing pretty good. I have exams coming up. I gotta be prepared. I gotta be prepared. So I'm doing my physics assignment right now. Uh, After finishing this, I'll be heading for was just existing, but now I gotta do homework because vacation is gonna end. Yeah, bro. Do your stuff, bro. Yeah, so I have to do this physics assignment within Monday, but I'm gonna complete it today, so there's that. I have a chemistry assignment to submit within Wednesday. I have to do that. I have a math exam on 7th of May, which today's already 3rd, so I have to do that. Yeah, it's not, it's just, why can't life let me just exist? No, you can't just do that. You know that, right? You know the golden rule, right? Okay, so the dielectric displacement inside. the dielectric material is going to be the same as outside of outside of the dielectric material, but still between the capacitance plate. Fucking hell, we got it. Yeah, yeah, we got it. So d of x equals epsilon 0 e 0. No, d of x equals e of x if x is between 0 and x1. If it's between the conductor, it's going to be e0 epsilon 0. If it's between x1 and x1 plus a. And it's going to be the same for outside because it's going to be x1 plus a greater than x and t. What we do in class, a plus b, the whole cube equals a cube plus b. Oh, yeah, 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 whole cube. Yeah, a cube plus 3a square b plus 3ab square plus b cube. Oh, those are some good formulas. What we do as homework, a plus b the whole cube minus I mean, at least the test is easier. We do as homework, a plus b the whole cube and x minus y squared the whole cube. That's pretty good. It's going to be a cube plus b cube plus, yeah, like the first equation, x minus y squared the whole cube will be giving x cube plus 3x square y square plus 3x y raised to 4 plus y raised to 6, right? It's pretty good. So you have math homework, I'm guessing, right? They get us studying for 69th grade while the test is easier than just laying down. Yeah. I mean, you should be happy that test is much better. Oh man, this in college it's going to be the opposite. They show you, they tell you real simple, but when the questions come, it's going to be use every formula and twist it and turn it and think of this and assume it and oh man, I did not know there was this complexity. So how do I convince the class that I got that formula? How? Geometry is going to be a pain. We only did 8 out of 20 cards we need, so we cooked. I mean, it's school, right? It's school life, right? Chill, bro. Just chill, dog. You're gonna be fine, dog. Just chill, man. How do I convince? D of x equals epsilon zero. D of x equals epsilon zero E of x. If it's between the conductor, E of x is. That's where the confusion came. What? Okay, what did I write? Okay, epsilon zero E of d equals epsilon zero E of zero epsilon E of d equals epsilon zero E of zero d of d equals epsilon dot E of d, right? Yeah, that's right. Epsilon into E of. Now we're gonna need a presenter in front of in front of a member of the board. This shit can take up a whole day because everyone needs to be present from 8th grade to 11th grade. So you have to present this in front of not students of not just your age, students of higher class. That's really, I know it's annoying, but I would say that is really good. Presenting something, it's a once in a life experience. It is an experience, I would say. It's bad, it's annoying, but you won't get chances like those. It's not in front of a whole room, it's in front of a one dude who knows geometry. Oh, it's in front of one person. Nah, that's weird. For me, it's like in front of the class. There's gonna be a teacher, and I gotta present the answer. That is, I don't know if it's a lot of stress, but it's some amount of stress on your head, and you gotta figure things out while you're in a stressful position. When is your test? Capacitance change. The capacitor becomes two capacitance in series. The capacitance becomes two capacitors in series. That's when. I don't think that's how it works. The geometry test, it is like an end of the year, so I got a bit of time. Okay, that's that's good. The capacitor becomes two capacitor. How? It's not a conductor, it's a dielectric slab. The problem is that I also got a project in social studies. Is that gonna be nearby, like this week or next week? How does the addition of the dielectric slab makes it a series like it almost looks like there is no difference in introducing conducting. It's like 16th of May. Okay. So the social studies project, do you have to do in front of people? Do you have to present the exercise? When the conductor is inserted electric field inside, no those differences. No field penetrates the conductor, so effectively acts like a perfect internal plate. Capacitance decreases compared to the vacuum case. Okay. Uh-huh. When a dielectric is inserted, electric field is not zero. No free charges induced yet, but we have regions of two different permittivity. The system is still analyzed as two capacitors in the series in terms of energy and voltage, but it's a conceptual tool. It's not an actual separation like the conductor case, okay? It acts like one. So the capacitance increases if E is greater than epsilon zero. It should be greater than epsilon zero because it's a dielectric. Does it ask how does the capacity change due to the insertion of the dielectric? Did I answer that for the first? If the conductor is placed at the center of the distance, the capacitance is higher. How is it higher than Caesar? Bro, what the region with the air and So addition of conductor increases the capacitance of the conductor. The requirements are kinda as for the project. You need to write it on 3 papers and you need 3 goals and say stuff about them. Then you need to get a product like a painting or make something 3D that is linked to the topic of the project. You gotta present all that in 5 minutes. Looks like a task. Looks like a good task to me. So did you choose a topic? Did you chose? Didn't choose yet, but I'm a bit of a procrastinator. Welcome to the club, bro. Welcome to the club. Man, procrastination lives forever. So, from my latest understanding, that adding a conducting material between a capacitor also increases the capacitance. Adding dielectric material also increases the capacitance. But the time you have to present is nowhere near enough for the sheer scale of the project. Okay, but you gotta do it right. I think they're gonna give you more than 5 minutes, but I think you have to uh shrink it. Yeah, in 5 minutes. It's a good how do you say that? It's a good way to balance. You can present 3 papers in 5 minutes, yeah, but you gotta. I actually like the 5 minute stuff because do they ask questions like after presenting? Are they gonna ask any doubts or stuff like that? I think I'm gonna write it in a bigger font to be able to present. Yeah, I mean, it's gonna you're gonna present this in front of the class, right? So yeah, you gotta make the font bigger so everyone can read, I guess. Capacitance. Mhm. Bigger font, less text, less time, fits in 5 minutes. Damn. Damn, son, you got it, boy. That's how that's what you gotta do, man. Bigger font. That's the way to go. Mm, uh, It somewhat acts like a series of capacitor. CND plus CD by CND dot CD. Actually, it's the opposite, yeah. CND dot CD by CND plus CD, which is epsilon 0 A by D minus A into epsilon 0 A by epsilon 0 A by D minus A plus epsilon 0 A by A. Oh, damn, a lot of epsilon zeros. Epsilon 0 A by A into D minus A, the whole square. A into D minus A by epsilon 0 A into A plus D minus A, which A cancels, epsilon 0 cancel. Damn, that's a lot of fucking. Just give you epsilon 0 A by D? What? That's. Factorio actually gave me a reason to use info no. That's A by B equals X by Y, and how to find the numbers in it because the game uses ratios. Good, good step in the right direction. That's what I call it. Region with the dielectric is capacitance is E by A. Okay, that's where I made the mistake. Mhm. So it's Factorio now. I take the A as common epsilon 0 A plus epsilon D minus A and A into D minus A. Push, 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 push. Epsilon 0, epsilon by epsilon 0 A plus epsilon D minus epsilon A. Mm, I don't know if it's bigger or smaller. The parts in the A by B is called inner parts and outer parts. In Russia, that's okay, but means digs. Whoa. So that quickly became a joke of the people asking each other if they like inner parts or outer parts. First of all, do do you guys just keep talking to each other about inner parts and outer parts? What? I mean, yeah, I don't know. We also have inner jokes, so yeah, I'll give it that. Epsilon zero, come on, I can do the E. Hmm. I don't know if it's bigger or smaller. Keep in mind that this started in fifth grade. Okay, so the kids in Russia are more mature, I would say. I mean, I did not have dick jokes back in fifth grade. Oh man. Oh Lord. So the capacitance increases no matter if it's a conductor or a dielectric material, which is so unfortunate. They also started smoking real cigars in fourth grade. When the teacher took it from them, they went and stole it back. Yeah, I think I heard it from you. Well, that's Russia for you, eh? I mean, cigars. Oh, dude, I tried smoking cigars. That shit's not. It's not for a working normal human being. You cannot smoke that. Yes, so I did till the first two questions. Uh, I have to take a shower. I have to clean my room. I have to call. I got some stuff to do. Yep. Yo, Chulu. Uh, I'm a stream from. Should I close the stream? That's what I'm thinking. Should I just leave it open? I just do my stuff, and yeah, I think it's better to do that. Oh, So first, clean the room. Gotta clean my room. I'm gonna go get the stuffy. Also, be right back. Hello. Oh, റൂമിലാണല്ലേ? ആ ഓ ഓ വേറെ ഞാനിപ്പം ഒരു ഹോംവർക്ക് ചെയ്ത് വിട്ടു. ഇനി നടന്നില്ല. ഓ ഞാൻ വീണ്ടും സ്ക്രീൻ അടിക്കായി പറയാൻ വന്നത് മറ്റേ ലാപ്ടോപ്പ് വർക്കായോ? മോനെ അതോ മൈ മമ്മി ഇതൊക്കെ ഏത് പടം മലയാളോ? ഓക്കെ. ആ ഇത് സീരീസ് കാണാൻ പറയാതെ അല്ല ഞാൻ പറഞ്ഞല്ലോ. ഓക്കെ. ഏ ഓ ഞാൻ നോക്കട്ടെ. ഞാൻ ഇനി റൂം വൃത്തിയാക്കോ. ഞാൻ റൂം വൃത്തിയാക്കോ. ഓക്കെ. Freaking back. We back in the house. Clean that room, yeah. 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 Okay, where I gotta start? The fucking apples. Go to the apples, go here. This shit goes here. This shit, a lot of shit, man, a lot of shit. This shit goes here. Oh, yeah. And take the table, clean the table. I have to use water. I cleaned it fucking last week, but the small insects that gets attracted to these lights. Man, I hate these. This goes here. Gotta charge the tablet. And I have to charge my where is that's the cable. Showtime. Showtime. Let's see. Did you guys know? Did you know? So no. Yeah, that's pretty good. That's pretty good. Pretty good. I think that's it. I just gotta do the floors, and this room is clean as new. Oh my god, I've never thought it was this easy to clean the rooms, you know? It's so easy. You just gotta put your mind to it. If there was in my mind. All the socks go slow. And there's you. No. Damn, that's a large mosquito. He's not dead. I'm sorry, man. You're not dead, though. That's a large fucking mosquito. I think that's a male mosquito. Flies. Hey, hey. Yeah. Guess the room's pretty chill right now. Okay, that's done. Gotta do uh what's charging. Where's the mouse? Yeah. Rip mouse. Nope. Got him. Got him. Well. The last question. DeepSeek. Yo, answer the third question. Oh, I gotta charge my watch, which I can charge with my power bank, right? Yes, the power bank exists for that purpose. Okay, that's good. A capacitor with applied with a constant voltage by an external voltage source is dipped partially into a liquid bath with permittivity epsilon zero, I guess, because I cannot read epsilon. The liquid inside the capacitor shows a level higher than outside the capacitor. Okay. The capacitor stays connected to the voltage source when dipped into the liquid. What is the total capacity and the energy W stored of the arrangement with partially filled capacitor? Give an expression for the height of the liquid rise. Calculate the first force on the liquid exerted by the capacitor. Electric force is the first derivative of W of work or energy. How does this force relate to gravitational force on the liquid? Damn, that's not easy questions. Inserting a conducting plate increases the capacitance. Here's why. Mechanism of a capacitance increases. The key idea: reduced effective separation. A conductor inserted between capacitor plates shield electric field inside itself, effectively splitting the capacitor into two smaller capacitors in series. The total separation D reduces to D minus T, where T is the conductor thickness. Mathematical proof with original capacitance without conductor. Blah blah blah. Boring. What else? What else do I gotta do? Whoa. You didn't see nothing. You know what? You didn't see. Oh, be right back. What what was I doing? What's up? The ceiling. That's the oldest trick in the book. I'm sorry, man. You gotta hear that. I'm really sorry. She. What happened to the ceiling? I mean, you asked me what's up. It's the ceiling. No, yeah. There's always ceiling up, up, up there, or the sky. Oh, you can see the sky. Yeah, yeah. Man, I want to smoke one right now. I'm not tired. I'm just so. Oh, thin conductor. Capacitance may decrease. Depends on the setup. Okay. Okay. Don't need to be so harsh. Okay. Boom, boom, boom. I'm hungry. I'm tired. Yo, I'm gonna end the stream now. I'll be streaming in 2 hours. I promise, man. I promise I'll be continuing my stream in 2 hours. Rip stream. No, no rip. It's gonna come back from the dead. I gotta do this. If I don't stream in 2 hours, then that means I am a. That's what I am. I am So yeah, 2 hours. Chulu, I'm a head out, man. I'll be back. Be spita, dog. We spita.